Hello everyone, today's topic is integrating factors. Now when the differential equation is not exact, then we make it exact and solve it. Now the term that we multiply to the differential equation to make it exact is called integrating factor. Okay, so here is the table which shows when to use which integrating factor. If this is a general differential equation, mxy dx plus nxy dy is equals to 0 if this is 1. Okay, this is denoted by 1. This is the standard. Okay, if this is the standard differential equation where mxy means this is the function of xy and nxy means this is also the function of xy. Alright, so if this is the general differential form and if mx plus ny is not equals to 0, alright, if this is not equals to 0 and equation 1 is homogeneous, then the integrating factor is 1 by mx plus ny. Alright, now let us see one example from this type. Okay, now as you can see, this is a homogeneous differential equation because each term is having same degree. Okay, and this is not exact because when we will find del m by del y and del n by del x, then those two will not be equal. Okay, that is del m by del x, del m by del y is not equals to del n by del x. So this is not exact. So as this is not exact, we will make it exact and then find the solution. Okay, now just because this is homogeneous, and now we will find mx plus ny. Alright, so mx plus ny is equals to x into x square y minus 2xy square minus mx plus this is ny. Alright, so this is y and here this is minus x cube plus 3x square y. Alright, now this is equals to how much? X cube y minus 2x square y square minus x cube y, this cancels, plus 3x square y square, which is equals to how much? X square y square. This is not equals to 0, isn't it? Now mx plus ny is not equals to 0 and this one is a homogeneous differential equation, therefore its integrating factor will be if will be 1 by mx plus ny, that is equals to 1 by x square into y square. Alright, now we will multiply this integrating factor to the LHS of this differential equation to make it exact and find its solution. Alright, on multiplying this integrating factor to the LHS of this equation, we will only make it exact. Fine, we'll make it exact. So because after multiplying you can find del m by del y and del n by del x and that will be equal. So I'm directly finding the solution, that is for finding the solution we will integrate it. Okay, so here this is 1 by x square y square into x square y minus 2xy square dx minus integration x cube minus 3x square y into 1 by x square y square dy is equals to c. So this gives integration, first term is 1 by y minus 2 by x dx minus integration x by y square minus 3, this is by y dy is equals to c. Now on integration we will get it as x by y. Okay, so here we treat y as constant in this and here we only integrate those terms which do not include x. Okay, so this is minus 2 ln x minus this is 0, and this is minus minus plus 3 ln y, which is equals to c. Fine. Now this can be written as x by y. This is what? See, this can be written as minus ln x square plus ln y cube, which is equals to c. This is equals to x by y plus ln y cube by x square is equals to c. Fine. So this is the answer. So now let us see the second form, that is if mx minus ny is not equals to 0, okay, and the equation 1 is this one, mxy dx plus nxy dy is equals to 0. This is equation 1. Okay, so yeah, and this is of the form f1 xy y dx plus f2 xy x dx x dy is equals to 0. If this one is of this form, then the integrating factor will be 1 by mx minus ny. Alright, see, you can see from this table also. Alright, where f of x, this its meaning is that this will be the function of x and y. Okay, now let us see one example from this form. So see, this is the example from that second type. Okay, so here m is how much? X y square plus 2x square y cube. Alright, so if this can be written in this form, that is f of x y and into y. Okay, so let us see if this can be written in that form or not. If we take y common from here, then this will reduce to xy plus 2x square y square, isn't it? Now we can see that yes, this can be written in that form, that is y f of xy, and n is how much? X square y minus x cube y square. From here let us take x common, then this reduces to xy minus x square y square, isn't it? So what we can see that this is in the form, that is f1 xy into y dx plus f2 xy into x dy is equals to 0. Alright, this is in this form. Now we will find what? Mx minus ny. If any differential equation is in this form, either the differential equation will be directly be given in this form, or you need to reduce it in this form by taking like this y and x common out of that. Okay, so after getting it in this form, we will get to know that the integration factor is going to be 1 by mx minus ny, if and only if mx minus ny is not equals to 0. So here mx minus ny is how much? This is x y square plus 2x square y cube minus this is y into x square y minus x cube y square. Alright, so this is x square y square plus 2x cube y cube minus x square y square plus x cube y cube. Alright, so this 2 cancels and we are left with 3x cube y cube. This is not equals to 0, isn't it? So its integrating factor is equals to 1 by mx minus ny, that is 3x cube into y cube. Now we will multiply this integrating factor to the LHS of this equation. This is the LHS. Okay, after multiplying we will integrate to find the solution. So let me directly integrate it. Okay, and on multiplying this one, this is 1 by 3x cube y cube into xy square plus 2x square y cube dx plus integration 1 by 3x cube y cube into x square y minus x cube y square dy is equals to 0. Alright, now this is integration, this is 1 by 3 x square y plus 2 by 3 x, alright, and this is dx plus integration 1 by 3, let me take that 1 by 3 common only outside, and this is 1 by x y square minus 1 by, this is how much, y, alright, dy is equals to 0. Now this is equals to, here we will take y as constant, so on integration we will get minus 1 by 3 xy plus this is 2 by 3 log x, and this is 1 by 3, and here we will integrate only those terms which do not include x. So this first term is 0 and the second term is ln y is equals to, sorry, this is c, okay, c. Now we can see that 1 by 3 is common in all the terms, so let us take this 1 by 3 over here, alright. So this becomes minus 1 by xy plus 2 ln x plus, sorry, minus, this is ln y is equals to 3c. If a constant is multiplied by another constant, then we can take it as again c or c dash, okay. So let me keep it as c only. So this is equals to minus 1 by xy plus ln x square minus ln y, which is equals to c, alright, which is equals to, that implies 1 by xy plus ln x square by y is equals to c. So this is its final solution. See, here are more two examples from this second form. See, here also this is f of xy into y. F of xy means function of xy, okay. So this is also of that form. So here also the integrating factor is going to be 1 by mx minus ny, and this is also of that form, okay. So these are actually directly given in that form, but the question that we solved just now, that is this one, here it wasn't given in direct form, rather we reduced it into the standard form, okay. If a differential equation is neither of form 1 nor of form 2, then we will use this method to find the integrating factor, okay. So we know that the general differential equation is of this form, mxy dx plus nxy dy is equals to 0, isn't it? Now we will find del m by del y and del n by del x. Then we will subtract these two, okay. After subtracting, the term that we will get, that will be either somewhat similar to m or somewhat similar to n. Fine. So if it is similar to m, then we will divide m, else we will divide n. If we are dividing m in the denominator, then see, this is my minus nx, okay. So if we are dividing m in the denominator, then its integrating factor will be, if will be e to the power integration minus f of y dy. And if we are dividing n in the denominator, okay, my minus nx by n, if we are dividing n in the denominator, then its integrating factor will be e to the power integration fx dx. Alright, so let us see an example from this form, okay. Now we can see that this is neither of form 1 nor of form 2, okay. So therefore what we will do is, see, this one is m and this one is n. So we will find del m by del x, del m by del y and del n by del x. So now here del m by del y is equals to 2y and del n by del x is equals to minus 2y. Alright, now on subtracting we get this as my minus nx is equals to 2y minus minus, this is plus 2y, that is equals to 4y. Alright, now we can see that this is somewhat similar to this n, means we, after dividing n, we will get a simpler term. So we need to get a simpler term in order to get a integrating factor, okay. So the integrating factor, now we will be first dividing this by n, alright, and on dividing we will get this as 4y by minus 2xy, which is equals to minus 2y x. Alright, so now the integrating factor is e to the power, this is f of x dx, which is equals to e to the power minus 2 ln x. Alright, 1 by x is ln x, so this can be written as 1 by x square, because when this minus 2 taken over here, so this becomes ln x to the power minus 2, that is equals to 1 by x square. So this is the integrating factor. Now after multiplying the integrating factor to the LHS of this equation, we will get this as 1 plus y square by x square into dx plus, so here this is minus now, minus this is 2 by x dy is equals to 0. Now we will integrate both the sides. Okay, so on integrating this becomes 1 plus y square by x square dx minus integration 2y by x dy is equals to c. Alright, so here we treat y as a constant, so this is x minus y square by x minus this is, and here we integrate only those terms which do not include x. So here x is included, so this will become 0, which is equals to c. So finally we got this as x square minus y square is equals to c x. Okay, so this is the answer. Now let us see this example. Okay, so here del m by del y is equals to 3y square x plus 1, and del n by del x is equals to 4. Now del n by del x is 4xy square plus 2. Now on subtracting nx from my, we will get 3y square x plus 1 minus 4xy square minus 2. So this gives us minus xy square minus 1. Alright, now we can see that this is somewhat similar to m, isn't it? So therefore we will divide this by m, which gives us by, if we take y common from here, then this will become xy square plus 1. See, so this both cancels and we are left with what? Minus 1 by y, isn't it? So whenever m is divided in the denominator, that time the integrating factor is e to the power minus f of y, that is minus 1 by y dy, which is equals to e to the power integration 1 by y dy, which is equals to e to the power ln y, which is equals to y. Now we will multiply this integrating factor to the LHS of the equation to get the solution. Okay, so on multiplying this, see, or let me write it like this, y into xy cube plus y dx plus 2y x square y square plus x plus y4 dy is equals to 0. Now we'll integrate, and this becomes xy4 plus y square dx plus 2 x square y cube plus, this is xy plus y5 dy integration, this is equals to c. Now this is equals to, here we will take y as constant, so this becomes x square by 2 y4 plus xy square plus, here we will integrate only those terms which do not include x, that is 2 into y6 by 6 is equals to c. Okay, so this is the final answer.